Today is our third day of notes for the Unit 10A note packet. So let's all get to page 7 in our note packets so that we can begin. What we're working with today is called geometric sequences. Very, very similar to arithmetic sequences, meaning they could be recursive or they could be explicit. The only difference is that geometric now go up by multiplication. So if my sequence is going up, you're multiplying by a whole number. If it's going down, you're multiplying by a fraction. Okay? So again, arithmetic or arithmetic sequences go up by addition. Geometric now go up by multiplication. So with geometric, they have what's called a common ratio instead of a common difference. The ratio is what you're actually multiplying by. Again, they gave you both forms of the formula, and the one a sub 1 is the one that they actually use the most. If it's recursive, they have to give you the first term. So let's talk a little bit more about this by doing a couple problems. Let's take a look at number 1. And let's circle before we do that the explicit form that they're going to use a lot too. A sub n equals a sub 1 times r to the n minus 1. All right, going to number 1. Find the next three terms given of the recursively defined geometric sequence. Geometric tells me I'm multiplying. I'm actually multiplying by some number. And it looks to me like I'm multiplying by 2. So I'm actually going to set up my chart. So here is my n. Here is f of n minus 1 times 2. And here's my answer. Looks to me, because it's f of n minus 1, that it's a recursive sequence. Okay, my first term, they gave me the answer, is 6. So now let's find the next three. So the second term would be f of 2 minus 1 times 2. Well, f of 2 minus 1 is f of 1 times 2. F of 1 is 6. 6 times 2 is, you're right, 12. All right, so let's continue on. The third term, f of 3 minus 1 times 2. Well, f of 3 minus 1 is f of 2. F of 2 is 12. 12 times 2 is, you're right, 24. Take a look at your answer column. Aren't you multiplying the first guy by 2 to get the second guy by 2 to get the third guy? Well, the fourth guy then is going to be, we don't even have to do the math. What is it? You're right, 48. So the next three terms of this one would be 12, 24, and 48. Okay, let's skip number 2 and go to the next page. Consider a sub 1 being 2, and a sub n equals a sub n minus 1 times 4. Identify the first four terms of the sequence. Okay, so again, they're changing the notation. Instead of f of n, they're doing a sub n, which we're okay with. So this is going to be my n. This is going to be a sub n minus 1 times 4, and here's my answer. All right, they're telling me the first term is 2. No work done there. All right, the second term would be a sub 2 minus 1 times 4, which is a sub 1 times 4. A sub 1 is 2. 2 times 4 is 8. Good. Third term, a sub 3 minus 1 times 4, which is a sub 2. A sub 2 is 8. 8 times 4 is 32. It's recursive, so let's see if we can get the actual fourth term done without doing the math. It looks like I'm multiplying the first one by 4 to get the second one by 4 to get the third one by 4 to get, you're right, 128. So the first four terms would be 2, 8, 32, and 128. All right, there's a little bit more work to do with this problem. How many times did you need to multiply 2 by 4 in order to get a sub 4? Well, how many times did I multiply that 2, which is that first term, by the number 4 to get 128? Well, once to get the 8, twice to get the 32, 3 times to get the 128. So I multiplied by 4 3 times to equal a sub 4. Okay, what else are they asking me about this question? Use your conclusion in B to find the value of a sub 10. All right, so in order to get a sub 10, I'm going to need a sub 9. Well, let's see how this went. To get a sub 4, I multiplied it 3 times. So it looks like I'm going under 1 to get the term I want. So I'm going to have to multiply by 4 9 times in order to equal a sub 10. And who am I multiplying by 4 9 times? You're right, the 2. So it's 2 times 4 has to be multiplied 9 times. So not that's 4 times 9, it's 4 times 4 times 4 times 4. Well, I don't really want to write it all out like that. So I'm actually going to write it out as 4 raised to the 9th power. Doesn't that mean the same thing? It's easier to put in the calculator that way. So a sub 10 then comes out to be, quickly in your calculator, what do you get? 524,288. Okay. Last part to this question. Write an explicit formula for the nth term of a geometric sequence based on the first term, a sub 1, r, and the n. Okay, so let's write down the actual basic formula. A sub n equals a sub 1 times r to the n minus 1. Where did I get that from? It's right above. Remember how we talked about the formulas? Oh, it's not above. It's on the prior page. About the actual formulas of an explicit and a recursive geometric sequence. Well, this is the one for the explicit. So let's fill in what we know. A sub n equals, the first term came out to be, you're right, 2. My common ratio, what was I multiplying by? You're right, 4 raised to the n minus 1. Now, can I neaten this up? Can I multiply 2 by 4? No, you can't, because 4 is being raised to the n minus 1 power. So really, there's nothing else I can do. So it's right there. Now let's double check that this works. Let's find a sub 10. So a sub 10 would be 2 times 4 to the 10 minus 1, which would be 2 times 4 to the 9th. Isn't that exactly what I have above? Which comes out to be 524,288. So the explicit formula worked. It will give me any term I want. I don't have to have the term before it to get the next term. I can find any term with an explicit formula. All right, let's take a look at the next page, please. Let's go down to number 5. Write an explicit formula for the geometric sequence. Okay, in order to write an explicit formula, it's got to be in the form of a sub n equals a sub 1 times r raised to the n minus 1. So I need to know who a sub 1 is, and I'm going to need to know who, whoops, let me erase that. And I'm going to need to know who my r is. All right, let's see this. My first term is 1,000. That's easy. It's given to me. What do you think I'm multiplying by to go from 1,000 to 500, from 500 to 250? Well, I'm not going up. I'm going down. Looks like I'm dividing by 2, but I can't do division. What's another way of saying dividing by 2? You're right. I'm multiplying by 1/2. All right, so let's write our formula. A sub n equals 1,000 times 1/2 raised to the n minus 1. Okay, so there's my formula. They want me to find a sub 10 then. All right, let's use the formula to find a sub 10. So a sub 10 equals 1,000 times 1/2 raised, my n is now a 10, to the 10 minus 1. So it's 1,000 times 1/2 raised to the 9th power. All right, put that in your calculator. Let's see what we get for a sub 10. So hopefully you got what I got. It's a decimal, 1.953125. It didn't tell you where to round, so we're not going to round. We're just going to give everything we see on our screen. All right, let's take a look at number 6. Write an explicit formula for the geometric sequence. So the recursive is times 10, and the first term is 0.25. So let's see if we can write an explicit. So it would be a sub n equals a sub 1 times r to the n minus 1. I know my first term, so it would be a sub n equals 0.25. My r is, what am I multiplying there? What is it showing I'm multiplying there by? Yep, you're right, 10 to the n minus 1. So there's my explicit formula. They want me to use the formula to find f of 8. Well, f of 8 means a sub 8. So let's change that to a sub 8. Okay, so that would give me a sub 8 equals 0.25 times 10 to the 8 minus 1, or 0.25 times 10 to the 7th. Put that in the calculator, and a sub 8 comes out to be, boy, it's a big number. Wouldn't you like to win that at the lottery? 2,500,000 is a sub 8, or f of 8. Please remember, f of 8 means the same thing as a sub 8. Well, today's notes were quite short because it's basically just building on what we know. Instead of now having an arithmetic one or an arithmetic one, we now have a geometric one where we're actually doing some multiplication. So take a look over your notes, and again, whatever I didn't finish from the pages of the notes, and let's see, we covered today pages 7, 8, and 9. So whatever I didn't finish from those pages, you need to complete on your own and have them ready for class tomorrow.